Hello everybody, Leon here and welcome to another mathematics video. In this video, we will be using the trig ratios to find for missing angles in right angle triangles. So sometimes in a question, you may be given two sides and you're asked to find an angle in a right angle triangle. And you can also use the trig ratios to do that. So once again, let's recap what we know about the trig ratios. So the trig ratios are used to relate angles, sides of a right angle triangle. And we basically use them to find for missing sides and missing angles to solve any problems involving the right angle triangle. And of course, we must know to label the triangle. So the angle that we want to find in this case, we will consider that angle to be theta. So let's just say theta is here and here is the right angle. So the side opposite the right angle, we refer to that as the hypotenuse, and the side opposite theta, which is the angle that we want to find in this case, we will call that side the opposite, and the remaining side will of course be the adjacent side. So the side opposite theta will be the opposite. The side opposite the right angle, which is the longest side, would be the hypotenuse, and the other side would be the adjacent side. So of course, let's recap the trigonometric ratios. So we know sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. And of course, we can remember this using the mnemonic, which says, some old horses can always hear their owners approach, in which the first letter in each word represents these formulas or these ratios here. And also we can use so, ka, toa. So whichever one you want to use, it's up to you. My favorite is some old horses can always hear their owners approach. And just like with finding for our missing sides, we also need to firstly identify the information that is given. 2, choose the correct ratio based on the sides and so on that we are given. And then we substitute the numbers into the ratio. And then last but not least, we solve for the angle. So of course, you will need a calculator to find for your angle. You will need a scientific calculator. So you must have that to find for that angle, because you will need to find the inverse of the sine or cos or whatever ratio you're using. So let's head into our first example. So determine the size of the angle marked to the nearest degree. So we want to find this angle to the nearest degree. So let's identify what we are given. So we see this is the angle, so we can call this angle theta. So the side opposite theta would be the opposite, and the side opposite the right angle will be the hypotenuse. So let's put down all of the ratios. So some old horses can always hear their owners approach. So we have sine, cos, and tan. So we see we are given the hypotenuse and the opposite. So which one of these ratios has those two, the hypotenuse here and the opposite? So we see sine has both the hypotenuse and the opposite. So we use the sine ratio. So we can say sine theta is equal to the opposite over the hypotenuse. So in this case, we want to find for theta. So we can say sine theta is equal to the opposite would be 19 over the hypotenuse, which is 27. So we can either divide 19 by 27 and you'll get a decimal, or we can just leave the 19 over the 27 and then just solve from it from there. Whichever way you want to do it, it's up to you. So next we want to solve for theta. So we see we need to take over the sine, because we want or theta by itself. When we take over sine, the opposite of sine would be sine inverse. And the opposite of anything is the inverse of it. So the opposite of sine is sine inverse. So this will be theta is equal to sine inverse 19 over 27. And once again, you can divide 90 by 27, you'll get an answer. And you should get the same answers, and you will, not should, you will get the same answers I will get. So we can say sine inverse. So to find sine, we need to put the second function sine, and then now it's 19 over 27, and we press equal, and we will get an answer of theta being equal to 44.7, but they want the answer to this nearest degrees, so theta will be equal to 45 degrees, because we need to round that 44.7 to this nearest degrees. So theta in this case is equal to 45 degrees. Let's look at another example. So determine the size of the angle marked to the nearest degree again. So once again, we label our triangle. So we see theta is here. So the side opposite theta will be the opposite, of course. And the side opposite the right angle will be known as the hypotenuse. And the remaining side would be the adjacent side. So let's put down the ratios. So it's some old horses can always hear their owners approach. So we see we are given the opposite and the adjacent. So let's see which ratio has the opposite and the adjacent. So we see the opposite, we see sine and tan has the opposite and the adjacent. We see tan has both the opposite and the adjacent. So this will be tan theta is equal to the opposite, which is the opposite over the adjacent. So tan theta in this case is the one that we want to find, is equal to the opposite, which is 29, over the adjacent, which is 38. So once again, we can divide 29 by 38, but for me, I'll leave it just as the fraction because it's easier to work it out like that. Less steps. So to solve for theta, we see we need to take over tan, and the opposite of tan would be tan inverse. So this would be theta is equal to tan inverse 29 over 38. So we can say second function tan 29 over 38. And that would give us the value of theta being equal to 37.349. But remember, they want it to the nearest degree. So theta will be equal to 37 degrees. So theta in this case is 37 degrees. Now let's look at our last example. So we want to find the angle here again. So we just put in theta. So we see we are given, so the side opposite the right angle will be known as the hypotenuse. The side opposite theta will be known as the opposite. And the remaining side would be the adjacent. So it helps to label all of the sides. It helps to label all of the sides because as long as you finish labeling the opposite and the hypotenuse, the remaining side will be the adjacent side. So students tend to mix up the opposite and the adjacent, so you want to label all, just to stop any error from happening. So let's put down the ratios. So some old horses can always hear their owners approach. So we see we are given the adjacent and the hypotenuse. So which one has the adjacent and the hypotenuse? So we see cos has the adjacent and the hypotenuse. So we can say cos theta is equal to the adjacent over the hypotenuse. So cos theta will be equal to the adjacent side, which is 26, over the hypotenuse, which is 45. So we solve for theta. So the cos is here. We take the cos over to become cos inverse. So theta will be equal to cos inverse 26 over 45. So we punch it in a calculator. So cos, second function cos, which will give you cos inverse 26 over 45. And that would give us theta being equal to approximately 54.7056. But to the nearest degree, theta will be equal to 54. So this is 5 and more. So this will become 55 degrees. And that is how we find for theta in this question. So remember, the steps to find missing sides and missing angles, they are similar. Step 1, you label the sides based on theta. Step 2, you identify which one of the trig ratios you want to use based on the sides that you are given, and then you substitute into those values, and then you solve for whatever unknown you want to find. In this case, we were finding the angles. So simple as that. And remember, these trig rules only apply to right angle triangles only. So of course, I must leave an exercise for you to practice to make sure you have the skill. So we have 2 simple questions for you to do here. Take a picture of them and ensure to practice them on your own to test your knowledge. So with that, this has brought me to the end of this video, and I'll see you in the next one. Take care.